Great to see you here again. We're now in the second part of the sixth paragraph, and here we will be looking into the rules of inference for propositional logic. We're looking at all the possibilities and some examples, so we will define all these elements. And it's very important that you really understand all the different possibilities, how we will use the rules of inference and what those rules are. I would advise you to make them on a paper that you always have them with you. So when we will be looking at exercises and examples in the following sessions, that you can refer to your papers very quickly. And it's very good to do that for all the things we're seeing here, because it will help you to be quick in using those rules of inference, not only in this course, but also later when you will be dealing with IT problems. First of all, let's look at the truth tables and the rules of inference. I already said it before that when we want to say that a statement is true, that we of course always can use truth tables. Truth tables are in fact quite interesting, and we can in fact use those truth tables in certain cases. Unfortunately, when we have arguments with a large number of premises, that will make the truth tables very complex and in some cases even impossible. Just imagine you have 20 different propositions, 20 different premises, then you will have to make 2 to the power 20 rows to consider all possibilities and all combinations of those possibilities. Now, the rules of inference are interesting because you can use the rules of inference to prove arguments faster, and we will do that in the following videos. We will show how you can use the rules of inference to prove even complex statements. We look at the basics of the rules of inference, and of course we will be using them to resolve or prove complex statements. But let's have a look at some elements here. The first thing I want to introduce is what we call the law of detachment. The law of detachment is also called Modus Ponens, and it is one of the rules of inference that we will define and use. It's the expression of the tautology that we have P and P implies Q, then it implies Q. And what we look at, the way that we write this, we will write the hypothesis in a column. Under the hypothesis, I put a horizontal line, and under it is followed by the conclusion, which is indicated with the 3 dots, which mean therefore. So what we have here, P and P implies Q, therefore Q. So this is in fact modus ponens, one of the elements that we have. We have the normal, let's say, the description using the and the arrow and all those symbols, but we can also use it in this more useful way to write the laws of inference. We also can have a look at some example here of modus ponens to see what it really means. Let's have a look at a mathematical example. We can say that if the third root of 5 is smaller than 7/3, then the third root of 5 to the third power is smaller than 7/3 to the thirds. We know that the third root of 5 is smaller than 7/3. Consequently, the third root of 5 to the third power, which is equal to 5. And when we take the third power of 7/3, we find that it's 3/4, 343 divided by 27, which is approximately 12. It's not exactly 12, it's a little bit more if you would do the calculation, but basically to prove that the right-hand side is larger than the left-hand side, we only have to look at the first integer, and it's clear that from 12 this is in fact true. We can define the propositions. The first proposition is P is the third root of 5 is smaller than 7/3. And the second proposition, Q, is 5 is smaller than 7/3 to the third power. So what we say, the premises P implies Q and P, then we have the conclusion Q. So what we have as result is that all premises are true, then the conclusion is true again. So basically we have proven this with the rule and with using modus ponens. Now let's have a look at the different rules of inference, and for every rule of inference we can find the tautology that corresponds with it. First of all, we have the modus ponens, so P, then P implies Q, therefore Q. And we say that P and P implies Q, therefore Q. And this is the modus ponens that we looked at the previous case. We also have the modus tollens. Here we have the negations, not Q, and P implies Q, therefore not Q. So we can have the tautology where we have not Q and P implies Q, therefore it implies not Q. The next rule is the disjunctive syllogism, where we have P or Q and not P, therefore Q. So we can write it as the tautology P or Q and not P, then we have Q. The next one is the addition. In the addition we have P, therefore P or Q, and we can write it as the tautology P implies P or Q. The next one we have the simplification. So we have P and Q, therefore P. So we say that the tautology in this case is P and Q imply P. We have the conjunction where we have P and Q, therefore P and Q. And we have this as the tautology where we have the propositions P and Q imply that P and Q. And the final is the resolution where we have in fact P or Q and not P or R, therefore we have Q or R, and the corresponding tautology is P or Q and not P or R, therefore we have Q or R. So the tautology is written with the propositions. We have the total table with all the different rules of inference, the corresponding tautology, and the name. And it's very important that you have those all the time with you, because we will be using them in the different exercises, and you may use them, of course, on the midterm or the final exams probably, if you are studying this at school. Of course, in reality, you will always have all these elements with you so that you can use them every time you need them. Let's look at some examples. Example one. Example one is the statements that we have here, and we want to find the rule of inference. The statements we have, the temperature is above 20 degrees centigrade, therefore it is either above 20 centigrade or cloudy. We look at the two propositions P and Q, and we can say that P is the temperature is above 20 degrees centigrade, and Q says it is cloudy. We can now rewrite this, and we can in fact identify this as the addition rule. And it says P means the temperature is above 20 degrees. Therefore, it is either above 20 degrees or cloudy. So P implies that P or Q. I have another example to identify the inference rule. And we have the temperature is above 20 degrees centigrade and it is cloudy, therefore it is cloudy. We look again at the same propositions, P and Q, the temperature is above 20 degrees, Q it is cloudy, and we can use here the simplification rule, which says that P and Q, therefore P. So we have P and Q imply P. The fact that both of them are true means that the temperature is above 20 degrees centigrade. An example 3, consider the statements again. The temperature is not above 20 degrees centigrade, then we will not have a barbecue. If we do not have a barbecue today, we will have a barbecue tomorrow. Therefore, when it is not above 20 degrees centigrade, we will barbecue tomorrow. Now we have 3 propositions here, P, Q, and R. P, the temperature is not above 20 centigrade. Q, we will not barbecue today. And R is in fact, we will have a barbecue tomorrow. We can use here the hypothetical syllogism rule, where we say that P implies Q, Q implies R, therefore P implies R. And we see again the notation as the tautology of the propositions. So basically this is the first element about the rules of inference. Rules of inference are very important in proofs, and we will be using them, of course, in the next sessions. The next session will be typically about how we use those rules of inference to build arguments. We will start using those rules and we will prove theorems using the rules of inference. You're doing a great job. Step by step, we're getting there. You're looking forward to it, I hope. So I thank you for your participation and I see you in the next video. Thank you and bye-bye.